Right, I've given you time to turn in your stuff from yesterday, at least what you have. All right, some is better than none. You had a full hour yesterday to watch the videos, take the notes on the correct sheets, and to do the practice. And if you paid attention to the instructions, the practice was just evens or odds. So really, that's only 10 problems. And again, it's your choice, either the evens or either the odds. Every time that I have assigned evens or odds in the past, I always have some kids that think they can just do like the first 10 and they'll be fine. What are even numbers? Okay, good. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that was one set you could have done. And then what are odd numbers? Yep, 1, 3, 5, 7, 9, 11, 13, 15, 17, or 19. So it's either those or those. If you only did like the first 10, like you did all 10, well, sorry, you didn't all 10. Evens or odds is an important thing you need to know, especially for math. So yeah, you have to do either the evens or the odds. And the reason that I do that is because the more you work down the page, the harder the questions get. So you need to have some easy, some hard. That's why I'm like strict about evens or odds. Zen, you have a question about this? Okay. Anyone else needs the papers from yesterday? You can come grab them now. All right, ideally, if you guys had asked me in the beginning, that would have been better than just sitting for 5 minutes. All right, but I also need to remind you, I used to, when I first started teaching, have an absent folder, and then like when kids are absent, I would write down their names and they would go get it from the folder. I don't do that anymore. Now I just put everything in Schoology, so that way no matter how long you're gone, you have the stuff from at home. So if you want the stuff, you have to ask for it. I don't just give it out automatically, because really it's all in there. You could take notes on your own paper from watching these videos. All right, take notes on your own paper. This is from last year, so just don't pay attention to the announcement part. But yeah, this is your note sheet, because that's the one you would have taken notes on. Don't do this one as your practice, because if you turn in the wrong one, sorry, like, I don't know what to tell you, you need to follow directions. So like earlier today for algebra, someone did the entire note sheet, but that's not the same thing as the practice. Notice that for the notes, we usually don't do every single problem. We just do enough to where we understand it, and then you work on the practice. So really all that you would need to have on it are the ones that we did in the video, okay? And granted, when I made this last year, it was probably on a Monday, that's why I split into 2 parts. So there's that first part. Second part's in here, and you skip to 11 minutes. And then you get like the last chunk of the lesson, so like right there. Where was it recorded? Yeah. That little canyon classroom. All right, so yeah, that just like how I'm recording right now. Usually if I have something from last year, I'll leave it for you because it's still me teaching. It's everything that I would want you to know, but it's on you to watch it. And here we have extra time to like go over stuff like I'm doing right now. But like in algebra, we don't. And quite honestly, I'm going to be missing quite a handful of more days because we're in our competition season. I'm going to be coaching. I'm going to be in California for a number of days. You'll have stuff and you'll still have work to do. And I expect you to know it because we're not going to have time to go over it. Right? So if you have questions, you need to be either emailing me, you need to go to the other teacher's tutoring, you need to go to my tutoring when I have tutoring, but like, you can't just like assume that I'm gonna have time to go over it with you, because quite honestly, we don't. In math, there's so many standards that you have to learn. It's not like English class where it's like the same 5 standards all year, right? No disrespect to your English teachers, but like in math, we learn new things every single day. because we don't have time to like really slow down. So either way, you all take the same test. So if you decided to like fool around, not do it, that's fine. You're still responsible for knowing the content. So, do with it what you want. All right, but again, math lab, we can go a little more slower pace, so that's why I even have this pulled up to even review with you, because we have the time in math lab. So which from the notes, so we'll start with the notes, do you still have questions on, or that you think looks confusing and that you maybe want to do together? Then 16. All right. FYI, this whole paper is what we call a monomial, which is mono means what? One. So a single term expression times a polynomial, which poly means multiple or many. Sometimes they use polynomial generally, because like as you can see, this is definitely a monomial, the S, but in the parentheses is a binomial, okay? But they'll just use it generally. So basically a single term by a multi-term expression. All right, first one asked about the 16, so let's look at that on the note sheet. All right, and if you read the instructions, it says distribute. That's basically how you solve these. Whenever it's a monomial times a polynomial, you take that monomial and you distribute it. Distribute means you're doing what? Good. So essentially you're multiplying the outside number to everything that's inside the parentheses. Okay, so negative 2x distributed to what's all in the parentheses. And we multiply. So what's negative 2x times 3x? So negative 6 for the coefficients, and then x times x is good. So that includes your product rule, if you remember. Multiplying. When you multiply the same bases, you add the exponents. So like if you need to write that in the corner, I suggest it. If you already know, great. But that's how we get x squared. So it's x to the first times x to the first, you get x squared. All right, but we still have to multiply it by the second term. So what's negative 2x times negative 4? Positive 8x. All right. Then keep in mind, there's still stuff outside the parentheses that we haven't even touched. So just bring that down, plus 7x. How do you know when you're fully done with the problem? When there's no more like terms that need to be combined. Does the negative 6x squared have a like term? No, so just copy that one over. Doesn't go away, but it also doesn't have a like term. Does the 8x have a like term? What's its like term? So that means we combine that. And always keep the sign that is in front of each term. So combine normally means add. So I have a positive 8 plus a positive 7, which gives me a positive 15. So put plus 15. And when you combine like terms, you don't change the variable at all, or the exponent. Questions on that? All right, so now we're done. Also in the instructions, it says simplify remaining expression, which we did. And then final answers must be in standard form. Do you guys remember what that is from algebra? That would have had to be something you learned by watching the video yesterday. Right, so in algebra, you had another video and another practice to do. Also, both which should be kind of already, hopefully. is my answer in standard form right now? Okay, so either we're confused or we didn't do what we were supposed to do yet. All right, so here's algebra, right? I usually won't upload the notes on the sub day. I'll upload them after the sub day because I do really want you to watch the video and hear all the explaining that I do. All right, but now that the sub day is over, here are the notes from algebra yesterday. This one's fully completed. If you watch the video, which is what you're supposed to do, really not all of these would be filled in, but you can always go back and fill them all in if you really want to. Or do them and see if you're right. But standard form is written in alphabetical order. So alphabetical ABC order with the highest exponent first. Okay, so alphabetical order, meaning like if I have a problem with X's and Y's and maybe even Z's, what comes first in the alphabet? X. So like say here, I'll actually put an example. We'll give you 2xy plus x squared minus y squared. All right, what did we say comes first in the alphabet? So then look at the terms that have x's. If there's multiple that have x's, we want to write the one with the higher exponent between the ones that have x's. So which one will we write first? The 2xy or the x squared? Which one has a higher exponent on the x? I'll repeat the question. Which one has a higher exponent on the x? The 2xy or the x squared? X squared. So that means we write the x squared first, then the 2xy, because that one still has an x, and then the y squared, because that's all that's left. So alphabetical order is most important for standard form. And then if there's multiple with the same letter, you go in the order of higher exponent. So then when we go back to that problem we just did, is it in standard form already? Yes, because we have the higher exponent first. All that's in this problem are x's, so we don't even have to worry about ABC order there. So questions on that? All right, which others from the notes, and actually let me finish writing this in so that you guys can have it too. So standard form is ABC order, that's first priority. And then higher exponent. All right, if there's like the same letter. Questions? All right, any others from the notes? Aubrey? Number 4, you said? 24. Okay, so this one. Remember to follow your order of operation. So PEMDAS is what we normally call it. P stands for what? Parentheses. But really, it's any grouping symbol. All right, so like these brackets are a form of parentheses. We use them when there's already parentheses in there. So start from like the innermost parentheses and then to the outermost. So then, yeah, parentheses come first. So work out what's in here first. Can I simplify that anymore? No. Thank you. But look, I have something that I can distribute in there. So that is actually something that we'll have to do. So we're distributing that -5. What's -5 times 3AB? Good. And don't forget the AB. And then -5 times -2b squared. You sure it's negative? Yep. Okay, good. So plus 10b squared is negative times negative. So we did that. We still have other stuff going on in the problem. So I'm just going to rewrite it. All right, so everything in black just was brought down. So we distributed so far. In the bracket, is there anything in here that can be combined? Are there any like terms? No, so don't combine anything in there. However, we do have, well, I guess technically we're done with parentheses. Done with parentheses. There's no power to a power, right? So we're no exponent. Now we're on the multiplying, dividing from left to right. So this is being times by this group. So I have to distribute that 4b to each term that's inside. Okay, so times by everything in there. What's 4b times 2a squared? Good. So coefficient normal. A squared b. So I didn't have multiple a's to be the product rule. I didn't have multiple b's to be the product rule. So just rewrite them. And then keep going. 4b times negative 15ab. So 4 times negative 15. Okay, good. I only have one a, so leave it there. And then what's b times b? Good. Now the next term, 4b times 10b squared. I get 4b. B to what power? Good. 1 to 2, 3. Questions on that side? All right, bringing down what was already there. Do I have any like terms? Okay, what are my two like terms? Good, and these are like terms because they have the exact same variables to the exact same exponent. Like this one looks similar, but it's not. It has to be a to the first, like how these are, and b squared if we're going to combine the coefficients. What's negative 60 plus 29? Okay. Did you say negative 31? No. Okay, good. And then AB squared, so that part doesn't change. Do these other parts disappear? No. So I'm gonna kind of erase what I have. So they should still be in the answer. So this is what we get from combining those. Let's kind of at the same time put them in standard form. So what would I write first? Only, and I'll highlight it maybe. Only this one and this one has an A in it. Which one has a higher exponent on the A? So that I should write first. A squared B. Then by default, this one would have to come second. It's the only other one with an A. And then again, the only thing that's left after that is the 40B. Okay. If you got that right on your first try, good job. Now we had a lot of steps, so one of the things we need to remember. But yeah, it's something that you'd have to learn how to do anyway. So I doubt there would be one that hard, like on a unit test. But if you really know it, then you know it. Done? Yes. Questions on the notes anywhere? All right, questions on the practice anywhere? I'll do no more than 5 on the practice. Because I don't want to do the whole thing for you. I mean, I want you guys to do well, but I also don't want you to use me to do your homework. Daily. Number 10. All right. So 10 was the first request. And in any sort of problem solving, usually the first step is to distribute, is necessary. So when you have stuff set up like this, something on the outside being multiplied by a set of parentheses, and inside they're like adding or subtracting, then you need to do that first. So what is W cubed times 3W squared? Good. 3W to the 5th. Right. 3 plus 2 is 5. That's how we got that. Table of 2. Can you tell me what W cubed times 2W is? Or sorry, table 3 under. Allison, Michaela, Desire, Stephen, and anyone from that group, tell me what W cubed times 2W is. Right, unless you're using your calculator to add the exponents or to multiply the coefficients, your calculator probably will not tell you what W cubed or times 2W is. All right. So multiply the coefficient with 1 times 2. So that's my big number, and it's positive, so it's plus 2. What's W cubed times W? W to the 4th. The rule is when you multiply the same base, you add the exponent. Right? And then bring down what you already have. All right, all that's left to do is add. Only operation left. Can I add any of these? Which one? Are they all like terms? I would disagree. Like terms have to have the same exact variable, which they are all W's, but it has to be to the same exponent. So like that W to the 5th, I cannot combine with anything, so I just rewrite it. And I'm writing it first because that would come first in standard form anyway. For the others, these are both W to the 4th, so I can add these. What's 2W to the 4th plus 5W to the 4th? Good. Don't change the exponent when you're adding. So there's that. I can't do anything more. It is in standard form because it has the higher exponent first. So we're done with 10. Good. Here. Yes. Any other requests? So we did 1 problem. I'll do no more than 5 problems for you. Did you say 20? Okay. So 20. This one, I like it. I think it's a really great test question. Write an expression in simplest form to represent the area of the shaded region. So notice these are rectangles, right? How do you find the area of a rectangle? Length times width. Now, if I want to just find the area of the shaded region, I basically have to find the area of both rectangles because they have a piece cut out of it. All right, so the area of the larger rectangle, so kind of work it out, it's going to be the area of the big rectangle minus the area of the small rectangle to give me that shaded region. Anyone disagree with me? Does that make sense? Yeah. I mean, you're probably going to, but so yeah, in order to figure that out, you have to find the area of both and then also subtract it accordingly. You have to find the big one and then minus the small one. So if the area is length times width of the big rectangle, I have 3x plus 2 times 4x. And I could write it the other way too, that's fine. But I need to find this first. And then subtract from it the area of this smaller rectangle, which again is length times width. So then it's 2x times 3x. Questions there. And really, technically, you should find these first. Getting crazy with all the grouping symbols, but really you should find each one first and then subtract from each other. So for the larger rectangle, if I'm multiplying these, you're essentially distributing that outside number to both the inside number. What's 4x times 3x? 12x squared, good. Tiara, can you tell me what 4x times 2 is? Oh, close. Got the x part right. Try again. 4 times 2. I think you did good. I think you just did 4 plus. This is a common mistake. So yeah, 4 times 2 or 4x times 2 is 8x. Then from it, we're going to subtract whatever 2x times 3x is. Lorel, can you tell me what 2x times 3x is? Oh, so x times x. Okay, good. All right, so multiply to find the area of the big one, multiply to find the area of the small one. Now we have to subtract them if we just want the shaded area. All right, we have to like set up a plan whenever you're doing these types of problems. Do I have any like terms to combine? Good, so only combine the ones that have the same variable with the same exponent. Keep the sign that's in front of each term. What is 12x squared minus 6x squared? A positive 6x squared. And then this 8x didn't just go away, so just bring that down. And that's really all we can do. Unless we know what x is, which later in this unit, you'll find out how to find x. Unless you know what x is, that's all you can do. Question? All right. Desire? Yes. Other questions from the practice? You know. 17. All right. So 2 places where we have to distribute. First, we're distributing this 4n to this trinomial because there's 3 terms in there. So it's like 3 different multiplication problems. And then you have this negative n times 3n times the negative n. So just one at a time. Table 6. What is 4n times 3n squared? No. Try again. What's 4 times 3? And then n times n squared. No, n to the no. Third. Okay, because it's n to the first times n squared, 1 plus 2 to the first. Make sense? Okay. So then table 7, what's 4n times n?
4n to the power what?
Nope, try again, you're close. Because this is 4n to the power of 1. So if I multiply it by another n, I get
2.
n squared. Good. Yeah. All right. Table 8, what's 4n times negative 4? That's it. 4 times negative 4 is negative 16, because it's a negative here. And then, is that it? Good. All right, so that's the first one. Now we gotta distribute this negative n, and make sure, keep the sign that's in front of each term. That's a negative n. If you just distribute a positive n, it won't look right. So then table 2, what's negative n times 3? Good. Table 3 was negative n times negative n. What does a negative times a negative give me? Yep, so it would be plus here. And then what's n times n? So they're both n to the first right now. The rule is you add the exponent to give me. Okay, good. So questions on that part? All right. Now that we've done, that's like really the hard part, is the multiplying, because you have to remember your product rule. I like this part. Do I have any like terms that I can combine? Okay, good. And let me actually ask it a different way. Since we also have to make sure ours are in standard form, is there multiple letters in this one, or is it all the same one? Okay, great. So then all we have to look for is the higher exponent. So actually, if this for me, I would start with this one and see, does this one have any like terms? And the reason I chose that one first is because it has a higher exponent. So no like terms, just copy it over. Are there multiple n squared? Yes, I have this one and this one. What's 4n squared plus n squared? 5n squared. And then there's no others. Next highest n is n to the first. Do I have another n to the first? What's negative 16n minus 3n? Negative 19n. So working it that way can also make sure that your final answer is in standard form. Or you can just rearrange it at the end. The question was on that. All right, any others? Or what? Slides. Okay, so then there's about a little more than 15 minutes remaining in class. I'll give you time to work on whatever you need to work on for this. So if you chose the evens, work on the evens. Chose the odds, continue the odds. But really, it's just 10 problems total. And if you need to resubmit it to get higher points, because you know the last time you submitted it, it was only like partially done, then do that. But I do want them turned in online And I'll be grading them from there. All right, questions?